Cubic function 2018 GCE. This is the cubic function that we have. It is y is equal to x to the power 3 plus x to the power 2 minus 12x. So this is our cubic function. So part A, use the graph to solve the equation. Number 1, x to the power 3 plus x to the power 2 minus 12x is equal to 0. So whenever they ask you to solve the equation, we always solve for x. Okay, we always solve for x. So how do we solve for x? So therefore, this is what we are going to do. So this is the equation that we've been asked to solve. So I'll say, so the general graph that we have, it is y is equal to x to the power 3 plus x to the power 2 minus, that is the general graph that we've been given. So equal to the equation that we have been given to solve. So equal to the equation that we've been given, it is x to the power 3 plus x to the power 2 minus 12x is equal to 0. So from here, we are going to cancel same terms. So x to the power 3 and this x to the power 3, they are the same. X to the power 2 and x to the power 2, they are the same. 12x, 12x, they are the same. So what do we remain with? So we remain with y is equal to 0. So y is equal to 0. So we'll go on the graph paper, y is equal to 0. So y is equal to 0, it is the x-axis. It is the x-axis. So we'll go where the x-axis is. So this is the x-axis. So this is y is equal to 0. So now how do we find the values of x? So the values of x will come from where x-axis, which is y is equal to 0, they are intersecting with the general graph here. So this is the general graph. So they are intersecting here at 3, at 0, and at negative 4. So the values for x are negative 4, 0, and 3. Therefore, x is equal to negative 4 or 0 or positive 3. So these are the values of x. Part 2, use the graph to solve the equation x to the power 3 plus x to the power 2 minus 12x is equal to x plus 10. So we are going to equate this equation that we've been given with the general graph. Okay. So this is the general graph that we have. So is equal to the equation that we've been asked to solve. So the equation is x to the power 3 plus x to the power 2 minus 12x is equal to x plus 10. So from there now we are going to cancel the terms which are the same. So this term and this term, this one and this one, 12x and 12x goes. So we remain with y is equal to x plus 10. So x plus 10, it's the equation that we have. So how do we plot this equation that we have? So we are going to make the table of values. So we are going to make the table of values for us to know where the graph is passing through. So the first thing that you are going to do, you are going to choose any two numbers from the range of x, or if you want, you can pick from y. There is no problem. So I'll pick what is the value of y when x is negative 3 and when x is 2? So I have picked two values when x is negative 3, when x is 2. So you can pick any two values. So if you want, you can say let x be 0 and let y be 0. Then you fill in these two boxes. So we are using this equation. So what is y when x is negative 3? So I'm going to say y is equal to, where there is x, we put negative 3 plus 10. So y is equal to negative 3 plus 10, that is 7. So there it is 7. So again, what is y when x is 2? So I'll say y is equal to, where there is x, I'll put a 2 plus 10. So y is equal to 12. So when x is 2, y is 12. So from there now, I am going to plot. Okay, negative 3, 7, 2, 12. So negative 3, 7. So this is negative 3. So negative 3, positive 7, it is this side. So you have to look at the range. So the range that we have is 2 centimeters to 10 units. So that simply means that this small box, it is 1. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so negative 3. So negative 3, 7. So negative 3, 1, 2, 3, 4, 5, 6, 7. So this is where my coordinate is. Then we have 2, 12. So this is 2, 10, 11, 12. So this is where it is. So I'm going to join those 2 points, making a straight line. These are the 2 points. So I'll make a straight line cutting the graph like that at all points. Okay, so it is cutting the graph here, here, and here. So you have to make sure that you label this graph that it is y is equal to x plus 10. And remember that we are solving. So we are solving for x. So we have drawn the graph. Now, how do we solve for x? So here is how we solve for x. So this is where it is meeting with the graph. So you come in the x-axis. So that is a dotted line. So this is where our answer will come from. Then also from here. So here it is intersecting at the middle of the box. Okay, at the middle of the small box there. So it is also intersecting at this point. So this is where our 3 values of x will come from, here, here, and here. So we start from here. So this is negative 3, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. So negative 3.8. So we'll say therefore x is equal to negative 3.8, or this is 0. So negative 0.1, negative 0.2, negative 0.3, 0.4, 0.5, 0.6, 0.7. Now on the middle, it is 0.75. Negative 0.75. Or, so this is 3, 3.1, 3.2, 3.3, 3.4, 3.5. So these are the 3 values of x. Then part B, calculate an estimate of the gradient of the curve at the point where x is negative 3. So how do we calculate an estimate of the gradient? So for us to calculate the gradient, first of all, I need to draw a tangent. So drawing a tangent, where x is negative 3. So this is where x is equal to negative 3. So this is where we are going to draw a tangent. Remember that a tangent, it is a straight line that touches one point of the circumference of a circle. So that's where it will just touch from there. Okay, so make sure that you draw it properly. It must just touch from there. So this is a tangent. So where it will start from and where it will end, it is up to you. So if you want, it can start from here, it ends there, there is no problem. So I'm going to pick two coordinates. So number one, this coordinate. So this coordinate, it is negative 0.9. Negative 0.9, comma 40. Okay. So negative 0.9, negative 0.9 here, comma 40. This is 40. So negative 0.9, comma 40. Come here. This is negative 4, comma 4, comma 0, 1, 2, 3, 4, 5, 6. Okay, negative 4, comma 6. So these are the 2 points that we have. So how do we find gradient? Now we can apply the formula. So gradient is equal to y1 minus y2 over x1 minus x2. So the coordinates that we have, these are the two coordinates that we have. So we have negative 4, comma 6, and we have negative 0.9, comma 40. So this is x, comma y, x, comma y. So let this be x1, y1, x2, y2. So now I'll substitute in the equation. So gradient is equal to y1 is 6 minus y2 40, x1 negative 4, x2 negative 0.9. So that is our x2. So gradient is equal to, so we have negative 34 over negative 4 minus negative 0.9, we are going to have negative 3.1. So gradient is equal to 10.96. So that is our gradient. Part 2, calculate an estimate of the area bounded by the curve. X is equal to negative 3, x is equal to negative 1, and y is equal to negative 10. So how do we find area? So we need first of all to look at what shape is given for us to calculate the area. So we will go on where x is negative 3, where x is negative 1, where y is negative 12. So this is where x is equal to negative 3. So that is where x is equal to negative 3. So we'll go now where x is negative 1. So the boundary is the curve. And the last one is y is equal to negative 10. So this is where y is equal to negative 10. So the area bounded by the curve, this is the area that we are talking about. So depending on the method, that is very easy for you. So for me here, I'm going to make a trapezium. I'll just connect these 2 points. So this is a trapezium, and I'm going to calculate the area of a trapezium. So that is the area estimated by the curve. So this is my A from here to here. So remember that this is y-axis. So y-axis it is 2 centimeters to 10 units. So this is 10, 20, 21, 22. So the value for A is 22. And this is my height. So this is the x-axis. So x-axis is 2 centimeters to 1 unit. So 1, 2. So my height is 2. And then now this is B. So 10, 20, 21, 22, 23, 24, 25, 26, 27, 28. So B is 28. So area of a trapezium, it is half A plus B times height. So area of a trapezium, it is half. So A, that is 22. B, that is 28. Height, it is 2. So 2 and this 2 goes. So remember that you cannot divide these 2 into 22 or 28. No, why? Because there is an addition there. So 2 and 2 there goes. So area is equal to 22 plus 28. So the answer is 50. So 50 units squared. So that is our area. So question 2. The diagram below shows the graph of y is equal to x to the power 3 plus x the plus 3x to the power 2 minus x minus 3. So that is the general graph that we have. Part 1. Use the graph to find the solutions of the equations. So the first one is x to the power 3 plus 3x to the power 2 minus x minus 3 is equal to 0. So the first thing that we'll do, we equate this equation to the equation of the general graph. So that is the general graph. So is equal to the equation that we've been asked to solve. So which is, so we are going to cancel the like terms. So we have this and this, and this one, and this one, and this one. They are the same. So we remain with y is equal to 0. So y is equal to 0. It is the x-axis. So we'll go on the x-axis. That is where y is 0. So this is the x-axis. So y is equal to 0. So now where y is equal to 0 is intersecting with a general graph. That's where our answers will be. So remember that whenever we've been asked to solve, we always solve for x. So I'll solve for x from here. That is where the graph is intersecting with a general graph. So the values for x are -3, -1, and +1. So therefore, x is equal to -3 or -1 or +1. So those are the values for x. So part B, this is the equation that we have. So I'm going to equate this one with the general equation. So from there, I'm going to cancel the like terms. So this and this, this and this, this and this. So here, I remain with -3 and 5. So now I'll say y is equal to -3 plus 5. This -3 plus this +5. So y is equal to +2. So I'll go on the graph where y is equal to 2. This is y-axis. So remember that here it is 2 centimeters to 10 units. So this small box, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So where y is 2 is 1, 2. So that is where I'll draw a straight line. So this is y is equal to 2. So now where y is equal to 2 is intersecting with a graph. So we've got 3 points, this point, and this point. So I'll start with this one. So this is where our first answer will be. So this is negative 2, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. So negative 2.6. And then we have, this is where the graph is intersecting with a general graph. So this is where our answer will come from. So this is negative 1, negative 1.1, 0.2, 0.3, 0.4, 0.5. So negative 1.5. And then we have also this one. So this is 1, 1.1, 1.2. So x is equal to negative 2.6 or negative 0.5 or 1.2. So that is the answer. So part 2, calculate an estimate of A, the gradient of the curve at the point negative 3. So before we calculate the gradient, first of all, we need to draw the tangent. So how do we draw the tangent? We draw the tangent where negative 3, 0 is. So this is negative 3, 0. That's where I will draw a tangent. So this is a tangent. So this is negative 1, 20. Negative 1, 20. And this is negative 4, negative 10. So this is x, y, x, y. So x1, y1, x2, y2. So gradient is equal to y1 minus y2 over x1 minus x2. So gradient is equal to y1 is 10 minus y2 is 20. Then we have x1. So x1 is negative 4 minus x2 is negative 1. So gradient is equal to negative 10 over negative 3. So gradient is equal to, so the answer is 3.3. So that is our gradient. So the area bounded by the curve. So we've been given the boundary. So the boundary is x is equal to 0, y is equal to 0, and y is equal to 20. So x is equal to 0. It is the y-axis. So this is x is equal to 0. So that is the x is equal to 0. And this is the y is equal to 0. So this is the first boundary. And this is the second boundary. Then we have y is equal to 20. So this is y is equal to 20. So these are the three boundaries. So y is equal to 20, x is equal to 0, y is equal to 0. So the area bounded by the curve. So the curve there, it is the boundary. So I'll just connect from this point for me to make a trapezium. I'll just connect these 2 points for me to make a trapezium. So that is a trapezium. So this from here to there, that is B. So in the x-axis, it is 2 centimeters. So this is my B. So in the x-axis, it is 2 centimeters to 1 unit. So from here to there, that is 1, 2, 2.1, 2.2, 2.3. So the value for A, it is 2.3. Then we have the value for B here. This is 1. And then we have height. So height, it is 2 centimeters to 10 units this side. So it is 10, 20. So height, it is 20. So the value for A, it is 1. The value for B, it is 2.3. The value for height, it is 20. So 2 there, that is 1. 2 there, that is 10. So area is equal to 1 plus 2.3. It is 3.3 times 10. So area is 33 units squared.